given an f of x, and they say, what is the coefficient for the term containing x plus 2 to the fourth power in the Taylor polynomial centered at x equals negative 2 of f? So like always, see if you could take a stab at this video on your own before we work through it together. All right, now let's do this. So in general, our Taylor polynomial, p of x, it's going to have the form, and remember, we're centering at x equals negative 2. So this means we're going to evaluate our function at where we're centering it. We are going to divide it by 0 factorial, which is just 1. I'm just going to write them all out just so you see the pattern. And we could even say that's going to be times x minus where we're centering it. But if we're subtracting a negative 2, it's going to be x plus 2. And I could write to the 0th power. But once again, that's just going to be 1. So a lot of times you won't see someone write this and this. But I'm writing it just to show that there's a consistent pattern. So then you're going to have plus the first derivative evaluated at negative 2 divided by 1 factorial, which is still just 1, times x plus 2 to the first power, plus the second derivative evaluated at negative 2 over 2 factorial times x plus 2 squared. I think you see where this is going. And really all we care about is the one that has a 4th degree term. And well, actually, let me just write the 3rd degree term too, just so we get fluent in this. So the third derivative evaluated at negative 2 over 3 factorial times x plus 2 to the 3rd power. And now this is the part that we really care about, plus the 4th derivative. I could have just written a 4 there, but I think you get what I'm saying. And then evaluate at x equals negative 2 divided by 4 factorial times x plus 2 to the 4th power. So what's the coefficient here? Well, the coefficient is this business. So we need to take the 4th derivative of our original function. We need to take the 4th derivative of that original function, evaluate it at negative 2, and divide it by 4 factorial. So let's do that. So our function, so our first derivative, f prime of x, is just going to be, just going to use the power rule a lot, 6x to the 5th minus 3x squared. Second derivative is going to be equal to 5 times 6 is 30, x to the 4th, 2 times 3 minus 6, x to the 1st power. Third derivative of x is going to be equal to 4 times 30 is 120, x to the 3rd power, minus 6. And then the 4th derivative, which is what we really care about, is going to be 3 times 120 is 360, x to the 2nd power, and the derivative of constant is just 0. So if we were to evaluate this at x equals negative 2, so f, the 4th derivative, evaluated when x equals negative 2 is going to be 360 times negative 2 squared is 4. I'm just going to keep that as 360 times 4. We can obviously evaluate that, but we're going to have to divide it by 4 factorial. So the whole coefficient is going to be 360 times 4, which is the numerator here, divided by 4 factorial, divided by 4 times 3 times 2 times 1. Well, 4 divided by 4, those is going to be 1. 360 divided by 3, maybe I'll think of it this way, 360 divided by 6 is going to be 60. And so that's all we have. We have 60, and then in the denominator we just have a 1. So this is going to simplify to 60. That's the coefficient for this term.